All right, another day, another recording. We are going to start off with 6.3. So what are we going to learn today? We are going to identify some terms, define polynomial functions, review combining like terms, and then ultimately add and subtract polynomials, which is much easier than you're probably thinking. Homework problem set 6.3 on MathLab, and the lecture is this, which will be linked as soon as it's done. So, identifying polynomial terms and degrees of terms and polynomials. That's a mouthful. I don't even know if that makes sense, but there is a reason I don't teach English, and I will double check that. Anyway, a term is a number or the product of a number and one or more variables raised to powers, and the numerical coefficient or coefficient is a numerical factor of a term. So I know that's a lot of words, but really it's just this. Term is something like x squared y. The coefficient of the term x squared y will be 1 because it's implied that right in front of that x squared y, it is in fact 1 x squared y. Okay, same thing with the next one. We have negative z. It isn't, the coefficient there is -1 because the coefficient is just going to be the number in front of our variables. And in negative z, it's implied that we have a -1 z. We just don't write the 1 because 1 multiplied by anything is itself. So for that one, we have -1 as our coefficient. And then for our last one, we have x to the 9th over 7. And this is that idea that we have talked about in class where when we have something like this, 1/7 x to the 9th, it's assumed that we have it in the, that our variable goes in the numerator. And so when we have x to the 7th over 9, we know that that's actually 1/7 x to the 9th, and then we can see that the coefficient or the term in front of our variable is that 1/7. So basically, all you need to remember is that the coefficient is the number before your variables. If a term only contains a number, it's called a constant. So like 8. That's a term that only has a number, and that would be a constant. If we had 8x cubed, then our coefficient is 8. So a polynomial is a finite sum of terms in which all variables are raised to non-negative integer powers and no variables appear in the denominator. A polynomial that contains only one variable is called a polynomial in one variable. For instance, 3x squared minus 2x plus 7 is a polynomial in x. We see that it's a polynomial because all variables are raised to a non-negative integer power and there's no denominator. And then it's a polynomial in x because our variable is x. This polynomial is written in descending order since the terms are listed in descending order of the variables and the exponents. So descending order means largest variable comes first. So we have x squared, where 2 is our largest exponent. So descending order means that the largest exponent comes first. So 3x squared minus 2x plus 7, that's going to be in descending order. A monomial is a polynomial consisting of one term. A binomial is a polynomial consisting of 2 terms, and a trinomial is a polynomial consisting of 3 terms. Each term in a polynomial has a degree. The degree of a polynomial is the largest degree of all of its terms. So, for instance, I guess I should put instructions here. EX, identify the degree of the following polynomials. Don't say I never think on my feet. So, number 1, we have 7x cubed minus 3/4 x plus 2. Identifying the degree of a polynomial just means largest exponent. That's it. So we just look at our exponents and identify the largest one. So, for instance, in number 1, if we look at our exponents, the largest one is 3. So for our polynomial number 1, the degree is 3. For number 2, I'm looking at x to the 5th and x to the 8th. 8 is bigger than 5, so my degree is 8. For number 3, x to the 4th, that's the only exponent I have, so my degree is going to be 4. So again, when you're asked to identify the degree of a polynomial, you're just looking for the largest number in your exponent. So part 2, defining polynomial functions. A polynomial function is the sum or difference of exponential expressions. So that just means it's a polynomial defined, so a polynomial as we defined up here, but defined in terms of a function, so like given as f of x. So if f of x equals 3x squared minus 2x minus 5, find f of 1 and f of negative 2. So for this example, all we're going to do is the same thing as when we're evaluating normal functions. F of 1, we're going to plug in 1 every time we see x, and f of negative 2, we're going to plug in negative 2 every time we see x. So to find, for instance, f of 1, that's going to equal 3 times 1 squared minus 2 times 1 minus 5. And then you can do the math there. You can find f of negative 2, and you can challenge yourself and do number 2 as well, and I will provide those answers in class, and we can go over those if necessary. Part 3, combining like terms. All you have to remember for this is that like terms are the exact same variables raised to the exact same power. So, for instance, like terms, negative 5x squared and negative 1x squared. Unlike terms, 4x squared, 3x, because again, we have an x squared and an x. So our variables need to be the same variable to the same power. Example, like terms, 7xy cubed z, negative 2xy cubed z. Unlike terms, 12x squared y cubed and negative 2xy cubed. These are different because we have x squared y cubed and then xy cubed. Over here, they're the same. We have xy cubed z, xy cubed z. So for example, if we were to simplify by combining like terms, we have 3xy and 5xy. So 3 plus 5 is 8. So we're going to have 8xy. And then we also have negative 2x minus x. So negative 2 minus 1 is negative 3. So we're going to get minus 3x. And that is simplified by combining like terms. That is something that you should have learned in algebra, but if you need more practice with it, then basically all adding polynomials is combining like terms. So here's more practice. To add polynomials, combine all like terms. So let's go ahead and look at number 1 here. We have 7x cubed y. 7x cubed y minus xy cubed plus 11 plus 6x cubed y minus 4. So to combine like terms, I'm going to go ahead and identify my like terms, and then I'm going to go ahead and combine them. So I have 7x cubed y, and I have 6x cubed y. So 7 plus 6 is 13. So I'm going to have, oh, and then I also, yeah. So this guy, xy cubed, looks the same, not the same. It almost tripped me up, but then it didn't. So 7 plus 6 is 13. So we have 13x cubed y. And then we have this guy all alone, minus xy cubed, minus xy cubed. That has no like terms to combine with. And then we have plus 11 minus 4. 11 minus 4 is 7. So we're going to get plus 7. Final answer there, written nice and colorfully. So I want you guys to go ahead and try example 2. And then briefly, part 5, subtracting polynomials. To subtract a polynomial, add its opposite. So in other words, distribute the negative or the minus sign. So number 1, we have 3x squared plus 4x minus 7 minus 3x squared minus 2x minus 5. To subtract polynomials, we're going to distribute this negative. So we're going to get 3x squared plus 4x minus 7 minus 3x squared plus, not 4, I don't know why I wrote 4, plus 2x plus 5. And now all we do is go ahead and combine our like terms. So we have 3x squared minus 3x squared. Plus and minus the same thing leaves us with 0. So those actually cancel. We have 2x and 4x. 4 plus 2 is 6. We're going to get 6x. And then we have, Ms. Hogan can't play the tutorial making this video, minus 7 and plus 5. So negative 7 plus 5 is going to be minus 2. So we get 6x minus 2 for our final answer there. And then I want you guys to go ahead and try number 2 as well. And I'm going to go up to tutorial. Hopefully this video was helpful and you are able to at least try the problems. We will go over everything in class. And if you have questions, email me, come to tutorial, or we will go over it in class. Stop screen sharing and end.